We can combine our knowledge of one-step synthesis problems into multi-step synthesis problems where we begin our study of synthetic reactions. So we'll be doing this throughout the rest of the course and in the next semester. But we want to start here. We did a little bit in the last chapter maybe, but not that much. So notice here we've changed the position of a leaving group. Now how do you think we'll do that? So we've taken our bromine from this carbon and put it over onto the adjacent carbon. We can do that with a two-step reaction sequence where we do an elimination and then an addition to get us the product. So how do we do that? Remember that through Ch8 elimination, we'll pull off the H and Br to give us the more substituted alkene. And to get that, we use a small base. If we want the Hoffman product, we're going to use a big bulky base, but we want this more substituted alkene so that we can eventually add our Br over here. And so we're going to use our smaller base. Okay? And so this alkene will give us the addition product we want. And then we will, so in other words, we're going to use a small base to give us this alkene here. And then an addition reaction will put the bromine here. So the overall reaction is sodium methoxide to give us the more substituted alkene, and then HBr is going to give us H and Br added in Markovnikov fashion. So we've essentially moved our bromine to the adjacent carbon. So let's consider this transformation here. We're taking an OH group from this carbon and putting it on the adjacent carbon. We can also accomplish that in a two-step transformation where we do an elimination and then an addition of H and OH. So let's see how we would do that. We need the less substituted alkene, so we're going to get the Hoffman product, okay? And then we're going to add H and OH to give us the anti-Markovnikov addition. So in order to get that Hoffman product though, OH is not a good leaving group, so we're going to have to use tosyl chloride and pyridine to get the tosylate. Then we can use T-butoxide to form the Hoffman product, the less substituted double bond. Okay? So, putting that all into perspective, the first step with this alcohol would be to convert it to a tosylate using tosyl chloride and pyridine. Now we have the tosylate. Then through elimination, we can use potassium T-butoxide to give us the less substituted alkene. That's our Hoffman product. And then we can use hydration. We can use hydroboration oxidation to add H and OH across that alkene to give us the anti-Markovnikov product, which is going to put our OH on the adjacent carbon. So through these three steps, we've essentially moved the OH to the adjacent carbon. So we can also change the position of a pi bond in a similar way through an addition and an elimination. So you see here that we've moved this pi bond like over here. That's what we've done. That's not a mechanism for that. So we're going to combine two processes here. The first will be an addition reaction, adding HBr. In this case, we need the bromine to go anti-Markovnikov, and then we can do an elimination to give us the Hoffman product. So here's how that's going to work. We're going to use HBr with ROOR to give us the bromine on the less substituted side, and then T-butoxide is going to give us the Hoffman product with that big bulky base. So let's see if we can identify the reagents we've used to accomplish these transformations. So essentially what we're doing, we're moving this chlorine over here, and that's not a mechanism, I'm just showing kind of the overall reaction. So in this first one, we're going to have to do an elimination to put, let's change colors here, an alkene here, right? And then we're going to have to do an addition of HCl to move the Cl over there. Okay, so let's draw it out. So in the first step, let's bring it down here. I think I've got more slides for this, so that's no problem. In the first step, we're going to do an elimination with a small base because we want the more substituted alkene. That's going to give us this intermediate product here, and then if we just use HCl, that's going to add to the more substituted side of the alkene, giving us chlorine here. Alright, so we've moved our chlorine. So for the next one, what did we do? We moved our OH group over here. So, we need to do an elimination reaction, and we can't just use sulfuric acid and heat that up because that'll put our double bond in the wrong spot. So we have to create a tosylate here. Okay, so in the first step, we're going to use tosyl chloride and pyridine to create the tosylate. Okay, next we're going to do an elimination reaction with our small base because we've made our OH into a good leaving group. And next we're going to add OH, anti-Markovnikov, so that's our BH3, THF, H2O2, NaOH, and that's going to give us our target molecule, which was the one we were looking for. Okay, so for the next one, we're going from left to right. So what did we do? We changed a bromine into an OH and moved it one carbon over, right? So how are we going to do that? Well, that's pretty simple. Let's use a big bulky base. So what are we doing? We're pulling off a hydrogen from over here. We're pulling off HBr. It's going to give us an alkene. Do I have enough carbons here? Yeah, I think so. And then we're going to use our BH3, THF, H2O2, NaOH to add the H and OH, anti-Markovnikov. That will give us our target molecule. Alright, thanks for watching, and I'll catch you in the next chapter.